we need to find the horizontal and vertical components of the force at pins B and C with a suspended cylinder that has a mass of 75 kilograms. The first thing we need to do is recognize that member ABC is a two-force member. If we draw it, and isolate it by itself, you would see that you would have BX and BY and AX and AY and no other forces being applied. So if I draw a line that connects those 2 points where those supports are, we will have forces that are being applied equal and opposite of each other. So they'll be along that line. So we would have something like this and this. Force at A and the force at B with known angles where this will be a 3, 4, 5. Because this is 2, which goes to my 4. This is 1.5, which would be my 3. So that's my angle. So that really simplifies this, and we can draw the free body diagram of just the member with a pulley on it to find what it is that we need. So if I draw this member, and assume my weight is negligible, I isolate it by itself, but I'm going to leave that pulley on it on the end. And I'm cutting that wall off over here, cut this guy off. I will have a weight pulling down on this end of my 75 kilograms times 9.8 meters per second squared. I'll have the force of the rope coming off the pulley, which has to be the same as that came down here, but I cut that off here. So that's also going to be 75 times 9.8. Then I will have my CX and CY reaction forces at the pin at the wall. And then I will have the force at B that I just determined the angle for already here. So I have FB, but I know that that angle is 3, 4, 5. So I only have 3 unknowns. So from there, I can do my equations of equilibrium, where I have the sum of the forces in the x direction, negative CX minus 75 times 9.8 plus 3/5 FB is equal to 0. Sum of the forces in the y, negative CY plus 4/5 FB minus 75 times 9.8. And then I will take the sum of my moments about point C I'll have the x component, or the x component of FB actually is along the line, so it won't create a moment. And so I'll just have the 75, this one here. Oh, I forgot to put my 75 times 9.8, and I made a mistake and I did not put my dimensions in my free body diagram, so let's do that now. This is 2 meters, and this is 0.5 meters, and this is 0.3 meters. So that will make it so I can find my moment arms. So my moment arm for this one will be the distance from here to here, which is 0.3 meters. And then I have the 75 for the weight going down. And it will be negative, causing a clockwise rotation, 75 times 9.8, and its moment arm will be 2 plus 0.5 plus 0.3, so 2.8 meters. And then I also need the y component of this FB because I think I already said this, the x component is along the line, so I'll need to put in that y component and it'll be in the counterclockwise rotation. So FB and the y component is the 4/5 and its moment arm is 2. Set that equal to 0, then I can solve for FB, and FB will be 1532.8 newtons. And then I can put that back in here to get Cy is equal to 183.9 newtons. And then I can put it into here to get that Cx is equal to 490.5 newtons. Now that is it's asking for the horizontal and vertical components. So I have the horizontal and vertical components of Cy, but I need to find the horizontal and vertical components at B. So to do that, I will do Bx is going to be 3/5 times FB. So 3/5 of 1532.8, which is equal to 1.23 kilonewtons. And then By will be 4/5 times FB, and that comes out to be 920 kilonewtons. So that way I have both that horizontal and vertical components like the problem asked.